Hi, I'm here to talk about our project, which is called MassBrowser. And I've done this project with my colleagues at UMass Amherst, Hadi, Amir, my advisor, and Amir Hussein. So by now, you are aware of the censorship problem. There are many countries that do applying censorship, trying to limit the users' access to the internet for some reason. And on the other hand, we have several tools to deal with it. We have commercial tools, free tools, open source tools. And the problem is that all of these tools still have some shortcomings, have some problems. And to mention some, we can say most of them are easy to block because we are seeing that they are not useful in censored countries. Some of the better ones are costly. They usually have very poor quality of service, or other things that they may not have a very good user control level. You don't have that much control over the application, or some of the more academical ways are very hard to implement, such as decoy routing or other approaches that may be useful in a few years, but not right now. And we say that the main reason for that is that these censorship circumvention tools, they try to solve many problems at the same time. They try to combine many properties together. So one problem is the circumvention. When a censor entity tries to block your access to a content, and you just want to get access to the content. But some people see the same problem as a problem of anonymity, when you don't want others to know what you are accessing, or the privacy, which you don't want your private information to leak. And our observation here is that most of the majority of normal internet users, they just want circumvention. And the main evidence of that is that they are just looking across the internet for open proxies of any application. For example, if you are wanting to go to a messaging application, you go search an open proxy for this, for example, Telegram, or normal HTTP proxies, or even you use an open free shadow SOC server. And using a free shadow SOC server is not a good thing, because another entity can see all of your connection. So our approach is different in this project, and it's a very polarizing idea. We just want to focus on circumvention. And then we let the user decide if he wants anonymity, privacy, and we can provide it as an optional feature. So we call this project MassBrowser. And we have several design elements in our project, which is detailing. We have a very detailed paper, but I'm going to go over a few of them today because of the time. And the most important thing is that we are able to do these things because we are focusing only on circumvention, and we may lose some of the privacy or anonymity, but we have some solution for that as well. So let's go over a few of them briefly. So first, we try to optimize the load in MassBrowser. And how do we do that? Let me give you a very brief introduction how this sort of censorship circumvention system works. So a major approach is the proxy-based systems, which you want to go to block content. It's blocked by a censored entity. You go to a proxy and gain access to that. And it's a very well-known approach. And most of these censorship circumvention tools doing the same thing. And we can do this thing. It's a good approach. The next approach, which is a more clever way, is that there are many websites that provide their contents on these sort of CDNs, content delivery networks. And so if you, for example, want to go to Twitter, you usually don't go to the Twitter server itself. You go to some of these CDNs, edge servers, and there are copies of the same content on those edge servers. And there is a technique which is called cache browsing, which you can get access to those content without the censors actually knowing which content you are accessing. So, and our approach in MassBrowser is that we try to leverage all of these things to optimize the load on proxies. So the first idea is that if a content is not censored, we don't need to proxy it. And so we whenever a user starts a connection, we first look at the connection. Is that content is censored or not? If not censored, so we don't do anything. We just let it go directly to that content publisher, and it's the best quality of service for that user. Then we check if the content is cache browsable. Then again, it goes directly to that CDN edge server. It's a better approach, and it has very fast connection. And if none of these things works, then we try to provide access using the proxying system. And we call the proxies in MassBrowser bodies, and I will call them the bodies in this talk as well. And our evaluation showed that more than 40% of the contents in the top 1,000 Alexa websites are actually cache browsable. So this will reduce the load on the proxy significantly. And moreover, not all of these websites are censored in the first place. So you may not have to use these things as well. And so the next design element is that we use a volunteer-based system similar to many other systems. And the unique feature of us is that we use clients to help other clients. So let me give you a brief overview of our system. If you want to look at the MassBrowser at a very high level, this is some sort of a sketch of this. We have some users which are not in a censored country. They have access to a free internet, and they are running as a proxies, which we call them bodies. We have a management entity, and we have some users which are in a censoring countries. So the normal approach is that we use these users which are not in a censored country to go to these open internet users and gain access to the contents. But what we do differently in MassBrowser is that we also use the censored users in these two countries to help each other. And what makes us believe that it's possible is that, OK, we go over all of these measurement studies, and we looked at the type of contents and how these contents are blocked in different countries. So we saw if a website, a specific website, is blocked in 2 countries, 3 countries, how many countries a website is blocked at? And we saw that more than 60% of the contents are censored in a specific country. So if a website is blocked in China, there is a very high chance that website is not blocked in another censored country, which makes us believe that if these two users in these two different censored countries can help each other, they can actually let them use internet easily. And if we go to very more specific, for example, news or political type of content, more than 90% of these contents are country-specific. And this actually makes sense because, for example, if some Chinese news agency, no one in Iran will care about that website, and no one will block that website. So if a user in China connects to a user in Iran, he can easily get access to that. And we don't need the users in an open internet country. So, and as an example, if we combine 3 of the big internet censorship countries, such as China, Iran, and Turkey, together, there are only 18 websites which are blocked in all 3. This might not be that correct. This is what we used of the measurement studies that currently exist. So you can refer to our paper from which measurement study we used, but this is what we found, that only 18 pages are blocked in all of these 3 countries. So this makes us believe that, OK, censored users are incentivized to install an application, to use an application. So let's use them to help each other. Then you don't need other users to help them. And the next step in designing the MassBrowser is to incentivize actual volunteers. So because maybe we need other volunteers as well. To do that, we designed the software to give a lot of access to the volunteers. So if, for example, you want to help other users, you are in an open internet, and you want to become a body in our system, you can actually choose what type of content you are OK with relaying. For example, if you are very OK, you can say, OK, I will proxy any type of content, or say, OK, I just will proxy news content. Or if you are very conservative, you can say, OK, I will just proxy Tor content, which I'm sure that it's always going to the Tor network. There is nothing bad going to happen to me. And also, we give a normal control to the user, such as controlling bandwidth and other stuff as well. And finally, we said that we allow users to have an adjustable privacy and anonymity, and we do stuff to minimize the cost for our application. So first, about the cost, we showed that we optimize the load on proxies, and that helps us to make the MassBrowser implementation much cheaper overall compared to any other current project. And we compared the same setup as the MassBrowser and the Tor's mix approach, and we showed that the MassBrowser is 200 times cheaper than the MIC. And we also showed that if a user wants to have privacy and anonymity the same way as Tor provides, we have the option in our software to combine Tor and MassBrowser. And we show that, for example, if you only want Circumvention, you will get a very good quality of service, very good access. But if you want same anonymity and privacy as Tor, you can combine these together. You can get the circumvention of the MassBrowser and the anonymity of Tor. And we showed that the quality of service of the combination is similar to the quality of service of Tor. And which we show that then we have this option for users as well. And finally, what is the current state of our project right now? This project is being under development about 3 years now, and there are many lines of code in the project, and more than 10 people working on this in different time periods. And currently, our code is being under code review and security audit by a well-known third-party company, and we are having internationalization as well. And the current state of the software, we have a working software. We have a Chinese version. We have it for different operating system, and we are working on an Android version, which we will release soon, hopefully. And our system is currently in an alpha-based mode, just alpha release. We have an invitation-only based system, but we have users and testers from all over the world. We have users from China, Iran, and Turkey, and all of them. And we are using a normal relays bodies to help us relay the content from them. And we also need your help. If you are in an uncensored region, you can become a body and help us proxy content for other users. If you are in a censored region or you want to test our software, you can become an early adopter, install the software, test it, find bugs, help us develop. And finally, we always appreciate your help in development because it's 2 PhD students and a hard project. And finally, I want to thank you, all of the people who helped us in developing this software in these 3 years, and I will leave with some good comments that we get in the past few years. Thank you.
We have plenty of time for questions.
Hi.
Hello. Great talk. My question is, we understand these different goals, censorship, evasion, or privacy, but an end user may not understand the difference between these goals or the distinction between them. So is there any effort when you're deploying this, or do you intend to make an effort to educate users about the risks or consequences that they might take?
So there are many answers to this question. We have a long discussion in our paper, and we can talk offline. But we explicitly tell in our software, this software is only for circumvention. If you want to have privacy anonymity, we have options, as I showed, that you can integrate Tor with our software. And we have some evidence that a normal user who wants to just go read some news or go to Facebook is not in that much danger in some of the censoring content. I'm not saying all, but the things that I read and communicate with people, they not in that much danger for just going to a Facebook. But for someone who is an activist, we explicitly say, don't use this software alone, use it by Tor or whatever you want to do. This is not useful for that.
We have a question in the back.
Hi, I'm Satvik from North Carolina State University. Great talk. I was wondering about the decision process where you decide if a website is subject to censorship or not. So I was wondering how you do that detection.
So as the Royals team and all of these measurement teams do, there are many measurement studies that find the list of censored websites in different countries. So we can get those websites and check along that list if some website is blocked or not. We also have a users. We can use a user input in our software. Just a user says that this website is censored. I want to get access to that website anyway.
Thanks.
Sure.
Eric Wistro, University of Colorado. Thanks for the great talk, and really thanks for pushing this to deployment and actually putting real users on that. I think I'd love to see more of that in academia. My question is about how buddies discover each other, and if you see any threats from censors doing Sybil attacks or other kinds of nefarious things in there.
So our software is a central software, so we have a backend which communicate with the bodies, and so the clients and the bodies don't communicate with each other directly. They go to the backend, all of them, then they use a obfuscation channel, and we share secrets between the client and the bodies to communicate with each other and this stuff.
And do you foresee any like censor threats that a censor Sybil attacks?
Yeah. So we use a algorithm to assign relays to the client, and we use a reputation-based system to limit this effect of the Sybil attacks.
Thanks.
Sure.
Victor Lopochak, KU Leuven. Buddies can whitelist certain categories for proxying through the MassBrowser. How are sites assigned to categories?
So we use a public database of which website is which category, and just we'd say, okay, if it, for example, BBC is a news website or whatever. And in some places which a website might be in two categories, we put them in two categories. So.
Have you analyzed whether, for example, you cover news websites in specific countries because certain services,
Sorry, I couldn't hear the first.
So certain lists of categories are, for example, focused on English websites. Are you sure that, for example, a Chinese news website is correctly detected as a news website in the system?
Not right now, I don't think. We didn't, for the things that for the language that our team understands, we have a Chinese person, I'm from Iran, and we use, all of us understand English, so we looked at those sort of websites, but not all of them. So, but the good thing is that we have an option if a user says that I want to get access to that content anyway, we have an approach to just proxy through Tor, and so we just use anyone who allows Tor. So we don't fail in that set.
Thank you.
So just to follow up on how the buddies discover each other, I don't quite understand. Do they use centralized backend to know about each other?
Yes, the architecture is centralized.
So what if this backend is blocked?
So that's the main question. So we provide several different channels for communication between bodies and the clients. So right now the main defense is using domain fronting, which is very useful in many of the MIC and many of the censorship resistant systems. But we show that even you can use a very low bandwidth, such as email or a normal obfuscated channel to communicate with the backend. Because the communication between the backend and client is very small size, so that works for, and we can even use a low bandwidth system.
Okay, thanks.
Sure.
I'm sorry, we don't have time for yet another question. So let's thank Milad again for a good talk.